Hi, here's Chris with a new Blender tutorial for you. Today I show you a basic rig setup to control a car. No custom rigging add-ons are needed, just Blender. After this tutorial you will be able to let drive a vehicle on a custom defined path. You define the driving direction and speed, and the car just follows. The wheels will rotate using the right revolution, even backwards if necessary. And the car driver behaves also realistic and moves the steering wheel according to the wheel's current direction. And all this happens completely automatically without setting dozens of keyframes. So let's see how this works. The goal of this tutorial is to have a rig that can be reused for other cars in the future. And before we start, we of course need a car. I've created an old Ford Lizzie here in a low poly version, and it's based on some components, the car body and the wheels here. And as you can see, the version here is not very realistic, but that's okay for our tutorial. And the car can't drive alone, of course, so I've built this guy, the driver, and the driver is controlled by the Rigify add-on. Here I can show it to you. The Rigify add-on is a rig system that can be used for free in Blender. You just activate it here in the preferences. As you can see, when I go into the rig, I can control the driver and move him around, and this helps me to place him into the car and do later some stuff. Okay, these are the elements you need for our tutorial, so let's get started. The first object we create is an empty object in the center of our car. To get the center, I make the following. I go here and select my wheels because I don't want the center of my car body object. It's somewhere here. I want the center of all my wheels. Then I move the cursor to select it, and the cursor will be placed here directly in the center of my model. Then I add an empty here. It's a cube empty, and I can set the size 0.5 for example. Before we continue, don't forget to name your objects correctly. This avoid confusion later. So what I do is I press F2 and say this is our car route. Okay, here we can see the name. It's selected and the name is displayed here. To see the route all the time in the viewport in the front, you can set this here in the object properties. Then we go here into the viewport display area and say this have to be placed always in front of all other objects. And now we will parent all important car components here to the car route, because if I move it, nothing is moved. And the important car components here are the car body here, and the driver and the steering wheel, and we place them here to this object. I can press Ctrl P and set this parent here. This is root car to a parent, and say keep transform to avoid moving. So when I move now the car route, the body and the driver will be moved. Okay, this is the first what we do. Okay, the next object is the rear axis. We will place an empty that have to be used as our axis controller into the center of the rear wheels and give it a good name. To do this, I select my both wheels, and with Shift S I place a cursor to the selected, and in my situation here the cursor will be placed directly into the center of the wheels, and it's the same position as this axis. Be aware of this, you have to use the exactly position for your axis to avoid strange wheel rotation. Okay, in this case my center is here, and I will place an empty with the arrow type here, so I can see the axis here, the X, Y and Z axes. I do the same as before. I put them in front and see it here. The next is to give it a good name again, and this one is now axis rear. Okay, great. Before we create the front axis, I make some organization. I have a collection that is called car rig controls. In this collection, all my controls like this empties are placed in. Here you can see, or you can find the curve path. It's a path for our way later, for our road. And I place now both axes or both objects into the collection, and we can see them now here in the collection. It's here the rear axis and the car route. To avoid always placing them into this collection, I select this collection, and while it's selected, all new objects will be created directly here. So okay, the next one is the front axis, and this axis will be just duplicated. I duplicate it, and then I select here both wheels and place my cursor again into the center, and I move now this axis to the cursor. Okay, here we have now the front axis, and I rename it, of course. It's the axis front. Okay, the next step is to create root objects for our wheels. I start with the rear wheel here, with this one, and place the cursor directly into the center of this wheel. And the next what I do is I create an empty, and this time it's a cube, as you can see. Great, and I change the size a bit. In this case, Blender, it's a little bit slow. Okay, and I do it here, 0.3 maybe. So it fits here the size of our wheel, okay? And the next is to give it a good name, wheel rear root, and it's in the rear, and it's the left hand root, okay? To have a better orientation, I will switch the name of this empty on. I do it here in front, and I show the name. Now I see the name of this rear, as it can be done here for this one too, and for this one. Very good. And now we have it here. Okay, great. The same will be done for the next one here. So I placed already my cursor here into it. Then I duplicate my object and move it here onto this position. And don't forget to rename it. So it's a wheel rear root right. Okay, the same will be done for our front wheels. So great, I move them, I duplicate them and move them to the front a bit and place them different. A small adjustment is needed for the front wheels. Their rotation center is a bit different. We need the front wheel centers to control the wheel direction later. So we shift the wheel parent position to get the right vertical rotation. So as you can see, our front wheels are rotating in this way, but we need not this axis, we need this axis, because they have to rotate around this element. So this is it's very easy. What I do now is first I go here into my body and place, in my case, I place the cursor here, and of course, I don't have to forget to have the right height here. And let's see here in the viewport, we can see the 3D cursor. If you want to see the cursor all the time, you can press Shift and here on into this place. You can do it everywhere. Then a small pin appear, and the cursor here, this tab, will always be displayed. So anyway, where you are, you see always your cursor. It's sometimes very handy to do this. So, okay, I have now the transform view here and have my cursor displayed. So I see my cursor is here in this position, but have to be placed in the position where my wheel is. So I take this value, copy, and place it to my cursor. It's here. And my cursor moves down, as you have maybe seen, and now I have it here. So the next step is to take this wheel root here and place it to the cursor. Now it's here, and the next step is to take to have it here, and I can now rotate it here. Now I rename it root left, but this time it's front root. Great. And the same will be done for this one. I rename it first, maybe rear and front. Great. The good thing is my car is directly built in the center. So this position of this cursor just have to be shifted to the other side, mirrored. So what I do here is I type in minus and my cursor appear here, and it's exactly here in this axis. Now I take my root here from the front wheel and place it here to this position. Very good. The last object we need to create is an empty that defines the position for our later car dynamics. The car body here have to move dynamically when it drives into a curve or hills or stops immediately. For the dynamics position, we use the center position of the car root of this one here. I move the cursor to this position, and we can adjust it later if we want, but we take it first here. This is a nice position. Okay, now I add a new empty. This time it's a single arrow, and we give it a higher size or a bigger size here. It's a bit higher than the car itself. And again, I show the name and or draw it into the front. And next is the name for this object, and the object name will be car dynamics root. Great. This is our new one. Here is it. Before we continue, do you like this cubic world style? Zacharias Reinhardt from CG Boost has prepared a great tutorial series how to create your own cubic worlds. His course teaches you how to build and animate beautiful low-poly 3D scenes from scratch in a distinct style using only free tools. Click the link in the video description and check it out. Okay, let's continue. Now we have all objects to start with parenting and basically with setting up the rig, so the exciting part begins. First we parent the main elements. That means we parent the car root and the car dynamics root separately to the rear axis root. And then we parent the wheels to their root empties. Okay, so we take here this car dynamics root, and then we select the rear and we parent it without or keep the transform. The same we do separately for the car root. Okay, so when I move this, then the whole car is moving, and here the car is moving, and this part is moving too. Great. So, and the next is we parent the wheels to their parents here, so we can rotate them. The wheel will rotate too. I take the wheel, I take the root, and then Control P and object. Now, when we move the root here, then you see the wheel moves together. The same we do for this one. This time I use Shift R. The Shift R repeats the last steps I've done, so it parent the wheel to this root, and the same will be done here. Wheel, the root, Shift R, and the root is here, and the same for this one, Shift R. Very good. The next step is to parent the wheel roots to the rear axis. In this way, the wheels can rotate independently, but still follows the car direction. The front axis has a special role I'll explain in some minutes. So let's take all these roots here, this one, and parent them to the axis rear, this one here. Okay. Very nice. Now you can see the whole car is moving, but the front axis here has a special role. Good. Now we let the rear axis follow the path here, this one. To do this, we add an object relationship constraint called follow path to the rear axis. So we find it here in the constraints tab, and here's the relationship area, and we take the follow path. And I take now the curve I've created here. It's a regular curve, as you can see, a Bezier curve, and this is our curve for the path. Okay. We don't activate. Again, I go again to this root here. We don't activate the animate path option, if you may do. Instead, we use a different value that moves the car on the curve. This is very important for our later work and to control the car position and speed, okay? We switch to the curve object and use the evaluation time value in the path animation tab. It's found here in the curve properties here, object data, and the path animation, and there you see evaluation time. As you can see, the car is already following the curve, and as soon as we change the value, it drives on the curve. But there's a small issue with the rear axis. It's placed at the wrong position on the curve. We can see it if we switch to the top. Here is the rear axis. And when I go to the curve, you see the axis is not placed on the curve. The reason for this is the axis world position. This axis was not placed in the world center 0, 0, 0 here. Here you can see the location. This is the location in the world, okay? And to correct this, we just clear the object world X and Y location. So I go to this axis, and here I can do it here, or I go to the object properties, and then I correct here this both values to 0. And now the axis will be placed on the curve. And when I go to the curve and I move it, then you see it follows the curve. Great. We don't change the Z position here. We don't change it yet because we need this position here to control the car height position. Our result is still not really perfect. The car has a fixed orientation. This can be seen here. When I click on the curve, you already seen it. When I move the value, the car is looking or watching directly or all the time in the same direction. We need some additional settings to let the whole car orientate to the path direction. Maybe you think it's this option here, follow curve, but it's not the right options. We need a more flexible solution to get a real axis behavior on the track later. What we need is a target object that the rear axis have to track to. And this target will be our front axis, this one. To save some time, first I reset here the position. I go onto the curve, and say 0. Now we have here the starting point of our curve. Okay, to save some time, we copy the object constraint information from the rear axis, from here, to the front axis, so we don't have to set the constraint manually. To do this, we select both axes, this one and this one. The active one, the brighter orange here, is the source, and the target is here, the front axis. With Control C, you can copy the information. If you don't see this menu, it's the default copy attributes menu add-on. You can activate this add-on in the Blender preferences. We copy the object constraint values here, this one, copy object constraints. And now you see the front axis moves directly to the curve position. And we see it here on the curve. And again, we must reset the X and epsilon here, these values to 0. And we have this position here. And now it's on the right position and has the right height. Because the front axis needs to be at the front wheels here, at this front wheels position, we add a temporary offset inside the constraint. So I go here, the axis front activated. I go now to the constraints, and here we have a value, an option, offset. Okay, so we move it a little bit to the front, so it have around the position of the front axis of the car. We can change it later, and now it's here and looks not bad. Now we add a track 2 constraint to the rear axis and correct the orientation if needed. So we click on the rear axis, and then we add a new constraint. It have to be track 2, and this axis have to track to the front axis. So as a target, we take the front axis here, or we type it in front, axis front, and now the car is not watching or tracking to the front axis. We have to correct the track axis here. So what we do is we set first the up axis. It's the Z axis. This one have to be up, and it's still not locking to this here. And what we need is we correct the Y axis, and it's in this time we use the minus value, not the positive value. If you press this, then the car is looking in this direction. But if you use this one, then the car is now looking or tracking the front here, this front axis, and looks fine. Okay, so we can move it a bit here to the front axis position, by changing the value here a little bit, and now all looks not bad. Good. As you can see, when I go to the curve and move this value, the car is now following the curve. Very good. So here we see it. It's looking not bad. Very nice. The car already drives well, but the wheels are not rotating. You can see it when I move it. Nothing happens. Okay. This is our next task. But before we set the wheel rotation, let's set some keyframes that helps us testing the animation. For my animation, I will not use the default value, 250. I will use 600, for example. So we have more frames and we can set the speed, the animation speed here, from the frame rate from 24 frames per second to 60 frames per second. It's faster. And when I press the space bar, then the car is doing nothing because we have not set some keys. So I go to the curve and first I set the evaluation time to 0 here. And I set the evaluation time for the frames the same like the overall frame amount. So I don't want to evaluate the car in 100 frames. I want to do it in 600 frames, a complete animation. And I set now on the first frame, I set now a key, insert a keyframe, and I do the same for the last one. And I type in here 600, what means the time is 600 frames will be evaluated. Okay, insert keyframe, and when I press and start the animation, then you can see my car is already moving, but into the wrong direction. The reason is very easy, because our curve here, there are two things. Our curve is going up. So this is a positive value. So first I do is I set a minus value and replace the keyframes. Now we see the car is driving into the right direction, but it's increasing the speed. If you like it, you can do this, but I do the following. I want a linear animation, so I go and select all keyframes, and here in the curve editor, here in the graph editor, here you have it, graph editor. You can change, by the way, you can change the view by pressing Control Tab. You go here into the area where you have your timeline and press Control Tab and can switch between the graph editor and the timeline. So I'm in the graph editor, I select all keyframes, press T, and I see this set keyframe interpolation menu, and I say the interpolation have to be linear. Now we have a linear way here, a linear curve, and when I press, the car immediately starts and is driving here into the right direction. Very cool. Good. Now we have a testing animation to test our further steps. Okay, and there is a small issue we have. After we have changed the overall frames amount, the front position, the offset of our axis front here, from the front axis, moved back. Why is this happen? Because you must know, when I go to the constraints and I set an offset here for the position of our front axis, then this value is equivalent or the same value like a frame number. So what it means? If we have 600 frames and here is a 3, it means the offset are 3 frames. So the starting point for the axis is 3 frames forward, okay, from our original frame position. Good. And because we had 250 frames before we set it to 600 frames, the value changed. Okay, so you have to change it back to the front axis, and it works very nice. I show you why I'm doing this. We have here the hill, and when I move my car to this position, then it's trying to fly away because our rear axis is tracking the front axis, and the front axis is not far away or not enough, or has the wrong position here. So what I do is I expand or move it to forward to the right position of my front axis around here, and then okay, then it's okay. This position can be changed later by changing the curve and so on. We do it later maybe. Good, I go back now, and you can, by the way, you can see it's not working and the car is very nice following the curve over here. Now I go back to the front position, or to the first curve position. And now we have the second thing, or the second issue. Imagine you want to start your car not from here, but you want to do it from here or another point. What I'm doing here, the car is always starting at point 1, or at the starting point of our curve. And as you can see, the evaluation time 0 means it's the starting point position of our curve for our object. So in this case, this point here is the starting point of our curve. But what if we want to have this point to be the first one? So this have to be the starting point at evaluation time of 0. This is very easy to do this. We switch to the preferences window. We have the preferences, and now we go to the curve tools. Here's this one. So in Addons, you activate curve tools. This is a very, very nice add-on for working with curves. As soon as you are in the edit mode, you get a new tab, this one, edit, and I move my cursor down, and now you have a lot of options. These options are not visible by default, just with this add-on, and now there is an option utilities, and if you go down, you see set first points. Now you can choose this point here and change the first point position for this curve. I can do it here if I want, or I can do it here. So let's do it here, and this is now our starting point for our car. Okay, so I suggest you this nice add-on, the curve tools add-on. It's free and already given with Blender. Just activate it. Okay, very nice. Now you know how to change the curve position or the starting position. So the next step is to set the wheel rotation while the car is driving. As you can see, the car is sliding over the curve and the wheels are not rotating. Okay. To achieve this, we use a driver in Blender. If you don't know drivers, let me explain it in very short words. A driver is a value of a source object that controls or drives one or more values of target objects. Okay, like a controller. So we call it driver, it drives something. For our project, we need a value to control the wheel rotation axis of our car. So the rotation value must be dynamic, means if the car stops, our wheels have to stop too. And if we change the direction, for example, backwards, the wheels have to do this also. And the speed must be also controlled depending on the car's movement. A lot of tasks. The main information can be achieved by one value, the evaluation time of our path object. Good. Let's switch to the evaluation time of our path or curve and define it as a driver here. As this is very easy in Blender, use the right mouse button menu here and select copy as a new driver, this menu point here. Now select the first wheel root here and paste the driver to the x-axis rotation. Why? Because here the x rotation rotates this wheel in this direction. If you are not sure about the rotation axis, you can switch them on in the viewport display here, and now you see which axis is related or which axis is used for this object. Okay. Before pasting the driver here into the x-axis value, be sure you have everything reset. So everything is set to 0 and the scale value is set to 1. Okay, and now we go here and paste the x-axis driver into this value. Paste driver, and now the driver of our curve is controlling the x value of this rotate or of this root here. Okay. So I can test it, I can go into the curve here, and when I move this value, then you can see the wheel is rotating. As we can see, there are two problems. First, the rotation speed, and then the direction is not right yet. So I show it to you. I move this a little bit up because we need this place or this area later. When I move the frames, the car or the wheel is rotating very fast and it's rotating into the wrong direction. So I click on this element and you can see the Z is moving clockwise. Okay, the reason for this is my car is moving counterclockwise on the path, so the rotation values I use must be negative. Okay, we have do some basic math to set the right rotation speed and correct the direction. To change the speed, we switch to the driver editor. I do it here. Here we have it, drivers. Okay. And in the driver settings, we change the type to a script expression. To do this, we click first here on this element. You have to select this axis here as this wheel root. And then you see this is a driver. It's on the x-axis Euler rotation. And if you don't see something, you have to press N to see the sidebar. And then go to drivers. And there we can see here these options for the driver, and we set it to scripted expression because we want to script or to change these values here. Okay, wait, I've clicked on the wrong object, so great. Okay, what we do now is we have to change first the rotation direction. To do this, we just negate the value by typing a minus before the value. So I do it here, minus. And as you can see, the result was changed now. And when I move one frame forward, then the Z is moving into the right direction because the value here that is used, you can see it here, is now the right one we need. Okay, good. Great. And the next is we have to change the speed. To increase the speed, we must multiply the evaluation time here. And to decrease it, we have to divide it. So as we can see, the car or the wheel is very fast. So we have to decrease the speed. Let's try it first with dividing it by 3. And now we can see, let's have a trick to see it. We have this corner here. Do you see this corner of our wheel? Now you can place a cursor at this position, and the corner must stay per frame at this position, okay, when I move it one frame forward. So for example here, this corner, I place the cursor here. It's a very good help for this. And you see the position of this corner must be the right one. Depending on your values, if you want to make it very correct, like me, then you place it here and you see it's not really correct. So maybe we will reduce it to 0.75. Okay, so let's change the cursor again, and now it looks really good. Okay, this is what we have done, and now this script here, this expression, results in a correct wheel, and the wheel is rotating very nice in both directions depending what we do. Okay, I switch back to this frame, this is timeline, and now you see when I move it, the wheel is rotating very, very nice. Great, you can work with these values here if you want, and depending on your wheels. Okay, in my situation, these values are very nice, and you know, with minus, with negative, you can change the direction, and with dividing you can decrease the rotation speed, and with multiplying you can increase the rotation speed depending on your direction and so on. But we are not working just with one wheel, with one rotating wheel. We work with all wheels. To copy the driver information to all wheels, we link the animation data with all others. So to do this, select all wheels. I do it here, this one, and of course this one. And as you remember, the bright orange one, the last selected, is always the source. And the source is delivers or provides the information to all others. Okay, great. Now press Ctrl L, then you get this menu. and to link the animation data to all wheels. So you can link animation data to all wheels. And now, as you have seen it, every wheel has the same driver information like this one. It's not an instance, the driver information will just be copied to all the wheels. So when I move it here, so you can see the wheels are now rotating, all the wheels are rotating. Very cool. You can use Control L to do this, or you go to Object, Link Transfer, and then there you have the same link animation data. So it's here the same, okay? So this is how to copy the driver from one object to all the others. All looks already very nice, but the wheels are rigid and don't rotate to the driving direction. So I can show it to you here in this curve. So let's move the car to this curve, and as you can see, the wheels are directing always to one direction, and they are rigid and don't move. We want to move the wheels or to rotate the wheels to the curve direction. So let's solve this. First, we switch to the front axis root object, this one here. And then we go to the constraints values here, to the constraints, follow path. And here we set the option to follow curve. Okay. This doesn't change something in our existing rig, but let us use the rotation values of this object to control other objects, okay? Or to give it to other objects. So now we see the front axis is rotating or following the curve because of this option. And this is very good, a good situation for our next steps. The next step is to switch to one of the wheels, of the front wheel roots here, and add a copy rotation constraint to it. I will do it here in the constraints menu. I go to the transform, and I want to copy a rotation from a target. And this target will be our front axis. So we choose the front axis, and now you see the wheel is now directing to the curve. So it has copied all the three values from this object, from the root front axis, to this root here, to this wheel root. But there is a small problem. The direction is right, but the wheel stopped. It's not moving anymore. It's not rotating anymore. This reason is very easy. Our driver for our x-axis rotation is overwritten by our constraint. Okay, so as you can see, we copy the rotation from the front axis, and there we copy all three axes. So we copy x, y, and z. But we need just the vertical axis to rotate just the wheel direction here. And we want to control the rotation by our driver, and the rotation is on the x-axis. So we disable the x-axis and the epsilon or y-axis, and just keep the z, the vertical axis, from our front. And now we see the wheel is rotating again, and it's moving or rotating and following the path. To do this for the other front wheel, you just copy this front wheel as target and this one as source. Now it's bright and orange. This is our target. And you choose copy object constraints. And now you see this wheel moves or rotates to the right direction. And when we click here, we see it has the same constraint and all options. And now this wheel is following the curve too, and looks very nice now and is moving in all directions we want. A very nice result. And if you want, you can of course change the front axis offset a little bit if you think this offset is not right here, and in this way you can control how much the wheels are rotating. So for example, when I move it very far, we can see it better maybe here in the curve here. And if you think this is not enough, so we can move it a bit far or back, and the car is changing, but I let it mostly in this position, so I move it a bit here. So let's say it's this position is on this front axis, and this is mostly the best And now it works, and as you can see, the wheels are rotating, the front wheels, to the direction of the curve. Very nice. If you don't have a steering wheel, then you are as good as done. But if you have a driver like me, so you can constrain the steering to the front wheel's rotation and to the driver's hands. So let's see how to do this. I move this a little bit down here so that we can see more. Great. First, we connect the front wheel rotation here to our steering wheel. Okay. Select the steering wheel like me and add a copy rotation constraint to it. So we are here in the constraints and we go to the transform and copy a rotation. Okay. The target here is one of the front wheel's routes. So I take it here and use this route here first. Now use the Z-axis only as target. So at the moment, all axes of the steering wheel will be overwritten by these rotation values, but we need just the Z-axis. If you don't really know where or which axis have to be overwritten, you can use the steering wheel here. You can select it, go into the object properties, and again, you can watch or display the axes of your object. Okay, and you can see here, this is the Z-axis, is the one we need to rotate around. Okay. So I go back to the constraints and let's see what we have to do more. For the mix mode, this one here, you set it to after original. Okay, I do it here, after original. This settings keeps the main rotation of the steering wheel object and mix the wheel rotation after the original values. Okay, so the rotation of our object here will be kept. And after this, the rotation or the current rotation of the Z-axis will be added or used for the steering wheel, okay? And for both, for the target and the owner, please set the space to local, okay? Local space. Very good. Now all values are given or done, and the steering wheel is now rotating together with the front wheels. To have a better control of the rotations and to see if everything is working, you can parent a driver's cam to the car. So what we do here, we parent a second cam or a camera to the rear axis. Okay, so I show it to you. I take this camera here. At the moment, it's the camera for the whole scene. We can see the complete scene. I take the camera and duplicate the camera. Okay, and now I change the name, driver, camera driver. Okay, and now I switch to this camera to be active. I can do it here by clicking on this icon. And now we have this camera here active. And this camera will be now parented to our rear axis. So I choose the camera in the outliner and I go here and click the rear axis here together. And now I parent it to the rear axis, but keep the transform. So this camera is now moving together with the rear axis. So when I go play, then you can see our cam is always moving together with the car, with the rear axis. To have a better view for the front, for the driver to control the rotations, now we go here into the view and the camera have to be active. And we go to view and then we go to camera to view. And now we can change the position here for this camera. Let's say like this. Okay. Bit around, so okay, and now we switch this off, and when I go to play and play it, then you can see the wheel is rotating. I hope you can see it here. I click on the wheel weight here. Now we see the wheel is rotating into the right direction. The wheel is now copying the Z-axis of our front wheels and is rotating, and this is very nice, a nice feature for our driver. To attach the car driver hands to the steering wheel, you can use the hand controllers of your driver rig. I'm using the Rigify add-on, if you remember, and so I switch to this add-on here, or to the rig, and activate the rig. And now we see when I click here on the hands, controllers. Then I can move the hands. And what I have now to do is I have to attach this hand to the steering wheel. Before you do this, you have to control if the wheels are directing into the front. This is okay. And now we use this position here and attach these controllers to the wheel. To do this, we go here, we select first the controller here, like I do, and I go to the bone constraints here, and I use the child of constraint, and as target, I use the steering wheel, okay? The same will be done for this bone or this controller, child of, and the steering wheel. Of course, you can copy between two bones if you want. So, okay, now I switch off or exit this rig here, and I can hide it a bit and switch back to my camera. And now when I play, you see the driver hands are controlled by the steering wheel here and moves. Very, very cool. Okay, I can see it here now. A very nice situation. If you want, you can, of course, give more controls to this rig. So if you don't want just to move the hands, you want to move maybe, let's say, the upper body here. So you can do this the same. You can go here and say child off, or you copy the rotation value if you want. And in my case, I think I will use copy rotation for the Z-axis or off the Z-axis of our steering wheel here. Okay, and now when I go back to the camera view, I see my driver is moving a bit. You see, this is looking, or this looks very nice and a bit more dynamic. The same can be done for the head if you want. It depends on what you want to do. Very cool. Maybe I do it. It's a very nice feature, and you know, I like to play around. Okay, here we have our driver, and here, let's see. No, I take this one. Okie dokie. And now I copy the constraint from this object. Copy bone constraints now, and go back to the camera. And when I drive, you see my driver moves his head to the rotation of our steering wheel, and it looks more dynamic. He's living a bit. Very good. Okay, so let's see what we have. I go to this cam here and I drive now, or I play the animation, and our car can now drive on a custom created driving path, and all is happening automatically. I switch to the other cam. Here we have it. Very nice. The car is following our road and the wheel rotates to the current car speed. Very nice. Okay. You can do some tweaks to attach the car to your driving path. You can change the car body Z position and edit the curve itself to get better results. So let's see what I mean. I go now, while it's playing, I go now here, for example. First, I see maybe when I play the animation, then I see the wheel sometimes hovers over the ground here. So what I can do now is I can go here and take this both axes and move them a bit down. So the wheels are diving a little bit into the ground. And now I see, now the car is fitting better to our situation. And sometimes if you have this here, you can change, for example, the curve. So here you can put it a bit up, for example, or you can move this curve a bit up slightly or to this direction. And in this way, you can now control a little bit how the car follows the complete path. And here, for example, I put it a bit down. And now it looks a little bit better. And if this is too much, of course, you can add more subdivisions here and subdivide the curve. And if you don't like this, so we can move it a bit down here, for example. And now the wheels are following the hill a little bit better. The same can be done here. We can move it a bit down. here. Okay, and look, okay, this look is not bad. And this is hovering a bit, so you can change this controllers and be always careful. It's a little bit tricky sometimes to change or to control everything, but it works if you take some time, and it looks not so bad. Great. So in this way you can tweak the curve a bit, and you can control the way the car is driving around and have a very nice result that looks like this. Switch to the other cam and we see all looks fine and the car is moving. Very cool. One more interesting option is to have a dynamic car body tilt behavior. So what does it mean? The car should move into the side when it drives into a curve, so it have to tilt. I've made some tests and developed a quick and dirty solution that works very nice in the most purposes. And to simulate car body tilting, we can use Blender's cloth simulation. Okay, so I show it to you how this works. First, we create a separate object for the simulation, and let's start here in the center of our scene to avoid problems. Okay, so I will build now the object. So I add, let's do it here in the car controls collection. I add a plane here. So let's see how it looks from the top. Yeah, okay, good. I switch to the first frame, so I can now let's switch to this. Okay, now I go to the edge mode here and merge them to center, and I take this edge here and scale it, let's say to 0.1, and then we extrude it, let's say to 2 meters. And to avoid problems, you can subdivide it a bit here in the lower part. This is my experience. It's not bad to do this here. Very good. This is our simulation object. Let's see, maybe it's a bit big. Yeah, I scale it a bit to epsilon, let's say 50%. Okay. Important is you have to work in the edit mode if you are scaling. And if you scale something and want to reset, use apply scale and apply rotation to have a default object. Okay, so this looks fine. And if you want, you can of course use less polygons, but this is a good experience I've made. Now we call this new object car tilt simulation. Okay, so car tilt simulation. Very nice. This object has to be invisible for the rendering. So we switch the render option in our car controls collection off. Okay, so this is our object and we don't want to see it in the final rendering, and I switch it off. But we want to see it in the editor and we want to see it overall. So great, here we have it. When I play the animation, nothing special happens, but the object is ready for the further steps. Now we add a cloth simulation to this object. To avoid the objects fall down, we will pin the bottom vertices, but let's first add a cloth simulation. So here we have it. When I play the animation, you see it falls down. So to avoid this, we add a pin group to it. So I go into the edit mode and choose these 2 vertices and create a new vertex group here and call it pins. And then I assign these 2 vertices to this group. This pin group is used for our cloth simulation. So I scroll down, and there in the shape area there is a pin group pull down, and there I choose my pins. What does it mean? This pins hold the cloth object at its position. So when I play the animation, nothing happens. Why? The simulation is working, you can believe me. The point is, there is no force that moves this object, and so the object cannot move to left or right, and the stiffness results in a very straight object. Okay? To see the result, we must parent the tilt simulation object to the rear axis. So I have selected it, and now I select the rear axis, and now I parent it and keep the position. But the next step is not just play the animation, it already works. The next step is to move this object to the position of our car dynamics root. So I click on this object, then on our car dynamics, and selection to active, and now our cloth object will be transferred or moved to this position. And when I play the animation, you can see the object is falling down. Very good. But when I play the animation, then we can see the simulation stops at some time. The reason for this are the cage settings in the cloth modifier. So we go into the cloth modifier here on the cage, and there we can see the simulation is starting at frame 1, but it's ending at frame 250. But our frame range is going up to 600. So I have to change this value to 600. And when I go back to the first frame and start the simulation again, now all is working and the simulation works on the complete path. But there is still a problem. Our object, our simulation object, is falling down. The next step is now to change the gravity direction. We do this in the field weights area of our cloth simulation. I scroll down and there we see the field weights. Here we set the gravity value to -1. So now when I play the animation, I start at frame 1, the object has the right behavior, as we can see, and moves up as we play it. Okay, as we play the animation, the object is moving up and following our direction. Very cool. To transfer the movement to the car body now, we parent the car dynamic root object, this one here, to the direction of our cloth simulation. So the root object can move with this cloth together. To do this, we select the car dynamics object here, this root, and add the simulation to the selection. So we have both selected, and the active one is our car tilt simulation object. And now we switch to the edit mode and select 3 vertices to get the position from. So I go into the individual mode. Wait, I have to first. Okay, now we see them both. First we click with this one and then this one, go into the edit mode, and now we click 3 vertices to get the position from. So let's say we take this one, and this one. So we have a triangle and like a line here, and now after the vertices are selected, we use them as parent by pressing Ctrl P. And now you see this option, make vertex parent. Now this object will be parented to these vertices. But as you can see also, this object was transferred. Why? Because the base position of this object was used to place it here. So we have to reset it. That's very easy. And we take this position here, and now I move this to the cursor. So this works. So I have moved this root dynamics root to the cursor's position. The cursor's position is at the position of our cloth. Now it's at the right position, and let's see what happens. A nice antenna is moving. Our car dynamic is now working, and as you can see, our root object is following this object or the cloth object. We can see it in the other camera too. You can see there is a small antenna moving around. Very nice. The next step is to transfer the dynamic tilt movement to the car body. To do this, we add a copy constraint to the car body, to this object here. And then we set the car dynamics root as the target to read from it. So we do this here. I click on the car body root, this one here. Now we go into the constraints. And now we go to transform and copy the rotation of our car dynamics root. Okay, so I go here back and take the rotation information. So what we have now is the car is moving. Wait, I go into the camera and the driver cam, and the car is moving with our car dynamics object. The problem is the z-axis is moving around. What we need is only the side moving and the front moving, or the moving of the car of the epsilon axis. Okay, as you can see, it's turned around. The reason is the z-axis of the car dynamics route. It's very easy to correct this. I go back to the first frame, I go into the car route body, go back to the constraint, and then we say not the z-axis have to be used, just the x and epsilon or x and y axes. So this both axes will be used and this one will be switched off. This means our car is moving now just to the front and to the side, related to the movement of our dynamics object here. So yeah, I would say we are ready now. Maybe not. So let's do some tweaks. So let's adjust the last value, the influence of tilting. So how much the car body is moving while we are driving the car, while the car is moving. So we can influence the movement, the car body tilting value, in the copy rotation constraint here of our car route here. And the influence is this value here, how much is moved. As you can see, the car is moving around a lot, okay? So we can, if we want, use a smaller value. So the car is moving not this much. And this is the value we use for our car. But before we do this, let's see how we can improve the movement a little bit. As you can see, the car is moving a lot, okay? So the reason for this is a simulation of like the car tilt simulation. And we remember the simulation for the cloths is controlled by our gravity. And the gravity is set to a value of 1. And in this case, -1. So to have the right direction to directing up. But the gravity tells us more information. The gravity is very low. It means the car is moving a little bit like, I don't know, slow in water, whatever. It would be much better if the moving would be more rigid, more like a spring, you know? So let's increase the gravity value here. And this can be very helpful to have a better car simulation. Okay, so I use, for example, a value of 5. This is our first value to see what happened. Now you see the car is moving a little bit more rigid, a little bit more like on a spring, you know? So when I increase this value to 10, for example, then our car is moving much more rigid. It's moving more like a car. So at this point, let's add some keyframes to our curve here, for example, to stop our car immediately. To do this, I click on the curve, go into the curve options here, into the data information, and we have the evaluation time, as you remember. And now I insert the keyframe at this position and duplicate the keyframe and move it some frames forward. This means at this point, the movement stops, nothing will happen, you see? And when I move it, it starts again. Okay, so I go to the first frame to start the simulation and let's see what happened. And you can see the car stopped and then waits for some seconds again and drives again, okay? Boing, and again. So now you can see what happened if you change here the car simulation, if you change the value of your gravity. So I increase the gravity to a value of -20. It's a lot, and so most people would not do this, but for our case it's great because now the car is behaving like we want, okay? It's a little bit much, but it's not a problem. We now go into the car body and influence the value, how much is moving. So I put the half one, so let's see what happened. Boing, and again, very nice. And now we drive over the hill and it looks not bad. Let's see what happened. Yeah, it's great. So, okay, very nice. Already the 0.5 value gives us a very nice behavior for the car. Maybe I reduce it again, 0.25. And now let's see what happened. Yeah, and very nice car is moving around. I switch this off and we see this looks really, really nice. A nice simulation. So we can see with the help of gravity values and the influence, you can create or you can adjust the tilt simulation. Good. There is one more point. Some of you may realize when we move the car, then the front axis and the back axis, the rear axis, are moving with the body. So we have this element here, the axis, and it's related or connected to our body and very rigid. Actually, only the body have to be moved or have to move, and the axis have to stay at the position of our wheels. And as you can see, they slip, they move here around. So let's correct this. So there is a good way in my situation. In my situation, I've built a car that is just one mesh, so all polygons are connected together, but we can bind this information here and the rear axis too. We can bind it to our wheels. To do this, we use hooks. Okay, maybe you already know hooks. So I go into the car here. I go into the local mode here, and now what I do first is I create a hook here at the center of our rear axis here. I put the cursor to this position here. It's around in the center. It's not very important it have to be in the center, but it can. So now I add a new object, a new empty, a small cube, and let's give it a value of 0.2 here. Yeah, it's okay. And we give it a name and we call it axis hook. Okay, here we have it. Very good. Now I go back to the mesh and I select the elements I want to use as axis. Okay. In this, or in our case, in my situation, I take this elements here, the same for this one, okay, and the same I do for the front here, okay. First I add them here, I create a new group, a new vertex group. There is already a group, I don't know why, what's happened, maybe because whatever. I delete it, I don't need it. So you create a new group and we tell it a name, hooked, okay? And we add these vertices to our hooked group sign. So now when I select it, all the vertices are selected or in the group. The same we do for the front axis, okay? So, okay, very nice. And we add them or assign them to. So let's select all, just control if everything is okay. Yes, it's good, it looks good. Great. Now I exit or I go outside of this mesh, and now I put a new modifier to our body here, to our car. I go to the modifiers and then I go to the deform area and add a hook modifier to it. And now I choose, you already know it, this hook. And the hook have to control the group we have created before. So the group is called hooked, and now this hook can move this object. Can see it? Great. I see I forgot something. When I move this down, then you can see in my situation this area is not moving. So let's see, what is this? Undo, undo, undo. No, all is fine. Good. Now I go here into this object, this one here, and maybe this one. And I add this vertices here to my hooked group assign. Great. Okay, when I move now my hook object, then you see, oops, oh, I forgot to, I've made too much undos. So, okay, now Now I move the hook and you see all is working. Okay, I think you got it. Now I go back to the complete view and I parent now this object, this axis hook, to our rear axis, okay, to this one. Now I pet object the parent, and now when I move this axis, then these elements are moving too. You see it here? Okay, so let's see what happened. I drive now, and now you see the car is behaving correctly. Yes, very nice. Now you see this is moving around, and the same is happening for the backside. So I move maybe the car cam a bit here, the driver cam, so we can see the rear side too. Okay, and now I move it and you can see the same. Oh, wait, I move it a bit up. Great. Now you see the same is happening here, and the car is moving very nice. The same in the front. So great. Good. This is what you can do with the hook. All looks very nice. I switch to the rendering view here to Eevee and let's play it again. Maybe I switch this car tilt simulation off and we see now a very nice result of our work today. Okay, guys, that's it. Now you are able to create your own car setups. This is just one solution in Blender and by far not perfect, but maybe it helps you creating better car moves. I hope you like this tutorial and subscribe my YouTube channel. Did you know I have online shops for digital assets? You can find them on Blender Market, Gumroad, Flip Normals, and even on ArtStation. Maybe you'll find a nice product there. I have a link to one of my shops here in this video. In this way you support me to create more free videos. Okay, that's all for today and thank you for watching. Bye bye.